Dear students, good morning. Once again, I remind you the points what you had learned in previous session of our class. What were the different motions you studied in your last physics class? Can you say they are uniform and non-uniform motion? For a body which is in uniform motion and is not having any specified direction, the body is said to be moved with the uniform speed. Example, if a circus performer who rides his bicycle along a circular track takes equal time for his every turns, he is said to be moved with the uniform speed or constant speed. Here he covers equal distances in equal interval of time. For a body which is in uniform motion and also with a specified direction, the body is said to be moved with a uniform velocity. Here the body covers equal displacement in equal interval of time. Example, a train covers a certain distance by moving at a constant speed of 56 km per hour. It is said to be moved with a uniform velocity. Here it specifies direction. Next physical quantity is acceleration. What is acceleration? Consider a non-uniformly moving body along a straight line. State whether its velocity remains constant or not. It is not. Its velocity varies with the time. That is, velocity of this body for any interval of time is not zero. It has different values at a different instant of time and at different points of the path. Can we now express the change in velocity of an object? To answer it, we have to introduce another physical quantity called acceleration, which is a measure of change in velocity of an object per unit time. How can we define acceleration? It is defined as a measure of the change in velocity of an object per unit time. What are the conditions to produce acceleration? Acceleration can be caused either by change in direction of motion or velocity, or change in magnitude of velocity, or both. Acceleration is equal to change in velocity divided by time taken. Mathematically, acceleration can be expressed as a is equal to v minus u divided by t, where a be the acceleration, u be the initial velocity, v be the final velocity, and t be the time taken. Its SI unit is meter per second square. It is a vector quantity. There are two types of acceleration. What are they? First one is positive acceleration, second one is negative acceleration. What is positive acceleration? The acceleration is to be positive if it is in the direction of velocity. Example, when a car driver is increasing the speed of the car, the acceleration will become to be positive, because velocity and acceleration both are in the forward direction. Second one is negative acceleration. The acceleration is to be negative when it is opposite to the direction of velocity. Example, when the same car driver applies brakes on his car, the velocity is in forward direction but acceleration is in backward direction. So the acceleration will be negative. This kind of acceleration is also called deceleration. Another classification of acceleration is uniform and non-uniform acceleration. What are they? Let me think about uniform acceleration at first. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal interval of time, then acceleration of the object is said to be uniform. We can define the uniform acceleration as a body is said to be in uniform acceleration if it moves with equal change in velocity in equal interval of time. That means its velocity increases or decreases by equal amount in equal interval of time. Example, freely falling body, which is an example of uniformly accelerated motion. Second one is non-uniform acceleration. An object can travel with a non-uniform acceleration if its velocity changes at a non-uniform rate, or it moves with unequal change in velocity, or increasing or decreasing by unequal amount of its velocity in equal interval of time. Example, if a car traveling along a straight road increases its speed by unequal amount in equal interval of time, then car is said to be moving with a non-uniform acceleration. Next, one of the most important topics in this chapter is graphical representation of motion. Generally, graphs are common method to visualize, illustrate relationship in the data about a variety of events. Graphical representation is a convenient method to present basic information of various events. Example, in the telecast of one-day cricket match, vertical bar graph shows the run rate of team in each over. In physics, to describe the motion of an object, we have to use line graphs which show dependence of one physical quantity such as distance or velocity on another physical quantity such as time. In your syllabus, you need to study two graphs which are the distance time graph and velocity time graph. Let me discuss about distance time graph. The change in the position of an object with the time can be represented in the distance time graph. The uniform motion and non-uniform motion of an object can be represented by distance time graph. In this graph, time is taken along the x-axis and distance is taken along the y-axis. In the figure given in the slide, graph 1 shows a body which is in uniform motion and graph 2 shows a body which is in non-uniform motion. Second figure or graph shows that its slope gives the speed of the object in given interval of time. We know that when an object travels equal distances in equal interval of time, it moves with uniform speed. Here the distance traveled by the object is directly proportional to time taken. The graph obtained is always straight line and with a slope or inclination. Look into the slide. In this figure, second graph shows that the slope of the graph is different from the first graph. The graph is shown as curved line. The nature of the graph shows non-linear variation of the distance traveled by the car with the time. What is the non-linear variation? It means the distance is not directly proportional to time. This graph represents non-linear motion or motion of the body with the non-uniform speed. What is the use of distance time graph? We can use the distance time graph to determine the speed of an object. Using the table as shown in the figure, time is given in minutes, distance is given in kilometer. 13 minutes, 26 minutes, 39 minutes and 52 minutes. In second row, 8 kilometer, 17 kilometer, 26 kilometer and 35 kilometer. Once again I read. Time, the first row, 13 minutes, 26 minutes, 39 minutes and 52 minutes, and distance is given in the second row, 8 kilometer, 17 kilometer, 26 kilometer and 35 kilometer. We can draw a distance time graph whose slope determines the speed of the object by using this data. To do so, consider a small part of the graph AB. This is the distance time graph as shown in the figure 2. Draw a line parallel to the x-axis from the point A and another line parallel to the y-axis from point B is the point where from you have drawn another line parallel to the y-axis. When you draw a graph, you have to take a convenient scale of choice which you studied in mathematics. Here, these two lines meet each other at point C to form a triangle ABC. Now on the graph, AC denotes the time interval T2 minus T1, while BC corresponds to the distance S2 minus S1. We can see from the graph as the object moves from the point A to B, it covers distance S2 minus S1 in the time interval T2 minus T1. That is, speed V is equal to S2 minus S1 divided by T2 minus T1. This is slope of the graph. Next we are going to discuss on velocity time graph. The velocity time graph gives the variation in velocity with the time for an object moving in a straight line. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. The uniform motion or non-uniform motion of an object can be represented by velocity time graph. The figure shows a car moves at a uniform velocity of 40 km per hour. The height of its velocity time graph will not change with the time. This is only the straight line parallel to x-axis. As shown in the figure, there is no any inclination of the graph. It is the straight line parallel to the x-axis. What are application of velocity time graph? One of the most important application is that area enclosed by the line graph with respect to the x-axis gives distance traveled by a body in the interval of time. We can determine the distance traveled by an object in given interval of time by using this graph. We know that the product of velocity and time gives displacement of an object moving with uniform velocity. Since velocity is equal to displacement by time, so displacement is equal to velocity into time. We use the same graph which is shown in this slide for this purpose. As shown in this figure, area enclosed by this graph with respect to the time axis or x-axis will be equal to the magnitude of the displacement. To know the distance moved by the car between the time intervals t1 and t2, draw perpendiculars from the points corresponding to the time t1 and t2 on the graph. The velocity of 40 km per hour is represented by the height AC or BD, and time t2 minus t1 is represented by the length AB, which is shown in the graph. Here we determine the distance S moved by the car in the time interval t2 minus t1. So S is equal to AC into CD, which is equal to 40 km per hour into t2 minus t1 hours, where AC gives 40 km per hour and CD gives t2 minus t1 hour. This multiplication gives 40 into t2 minus t1 kilometer, which is area of the rectangle ABCD. This is one important advantage of velocity time graph. What is it? We can calculate the distance traveled by the object in given interval of time. I remind you again, first application of velocity time graph is that we can calculate the distance traveled by a body in given interval of time. Consider the graph as shown in figure. This graph shows that the body is uniformly accelerated body. We are going to calculate the area of the shaded region. We studied area enclosed by velocity time graph with respect to time axis or x-axis gives distance traveled in corresponding interval of time. As shown in figure, distance is equal to area of trapezium ABCDE. Since trapezium is composed of two parts, one is the rectangle ABCD and second one the triangle ADE. That will be equal to area of the rectangle ABCD plus area of the triangle ADE is equal to AB into BC plus 1 by 2 into AD into DE. The upcoming two slides depict the states or different motion of an object graphically. A. Distance time graphs. See the slide. First graph shows that the body is at rest. Its slope is 0, so its speed is 0. Second graph shows that the body is moving with uniform speed. Third graph shows that the body is accelerated or it is not having a constant speed or velocity. It is non-uniformly moving body. Its slope is increasing with time. And fourth graph shows that the body is decelerated. Its speed is decreasing or speeding down. This motion is non-uniform motion. The slope is decreasing with time. B. Velocity time graphs. First graph shows that the body is moving with a uniform velocity. The slope of AB indicates that it is with zero acceleration. Second graph shows that the body starts from rest and moves with uniform acceleration. Greater is the slope of the velocity time graph, the greater will be the acceleration. Third graph shows that the body is moving with uniform acceleration and its initial value of velocity naught is equal to 0. Fourth graph shows that the body is moving with increasing acceleration. The slope increases with time. Fifth graph shows that the body is moving with decreasing acceleration. Its slope decreases with time. And sixth graph shows that the body is moving with uniform retardation and its initial velocity is naught is equal to 0. As theta is greater than 90 degree, the graph has a negative slope. Dear students, you are requested to work out the homework given in every class and maintain the notes updated. It will be always helpful for you. Thank you.